Okay, so today we're going to talk about postulates. And postulates we actually had on that Quizlet Live. Remember that word postulate? So we just haven't gone over it yet. A postulate is just a statement that's accepted as fact. You don't have to prove it. It's just accepted as fact. So a postulate is a statement accepted as fact. We're going to go through several postulates, and then on your assignment, we're going to pick which postulate fits. So these are postulates, just statements accepted as fact. The first statement says, through any 2 points, there's exactly one line. We've kind of talked about that. It doesn't matter if you have 2 points here and then a point over here, if I say A, B, and C. And then remember I asked you if A and C were collinear. 2 points are always collinear. Always, always, because you can always connect 2 points and make a line. If you have 3 non-collinear points, that always makes a plane. So 3 non-collinear. What's non-collinear mean? Not on a line.
Non-collinear.
A line has to contain at least 2 points. Can a line ever have 1 point? No, never, never can a line have 1 point. It has to have at least 2. A plane contains at least 3 non-collinear points. It can't have just 2. And if 2 points lie in a plane, then the entire line containing those 2 points is also in that plane. So when we go through and we start trying to figure out which postulate fits, you're going to see if it's talking about a plane, if it's talking about a line, or if it's talking about a line in a plane. The last 2 postulates, if 2 lines intersect, their intersection is a point. And if 2 planes intersect, their intersection is a line. So we've already talked about some of this. All right. You're going to have some problems where you have to decide always, sometimes, or never. So if it says points A and B are collinear, are 2 points always, sometimes, or never collinear?
Always.
Always. 2 points are always collinear. Now, if it starts giving you more than 2, that's when it could be sometimes or whatever. Question, Nathan?
What if they're like different letters? Like
That's okay. It's okay. Can a line contain only 1 point? Line R contains 1 point.
No.
No, never. Has to have at least how many? 2. Okay, 4 points are non-collinear. Always. Sometimes. Sometimes they're on the same line. Sometimes they're not. If 2 coplanar lines intersect, then the intersection lies in the same plane as the 2 lines. So do you think that intersection would be in the same plane if these points are always? Always. If you have 2 coplanar, if you have 2 lines that are in a plane, then their intersection would also be in that plane. There's no way it couldn't be because the line is in that plane. So always. Okay. So those are some of the types of questions that you'll have. And then you're also going to have some problems where you have to figure out which postulate. So, like this says, line M, I'm going to try to go back and forth to the postulates. So here's the postulates. So this says line M, so I'm going to make a line, call it M, contains points F and G and also E. So if I look at these different postulates, I know I'm talking about a line, not a plane. So I can already ignore this one, and this one. So if it contains like 3 points on it, which one of those postulates do you think it might be?
2.3.
2.3. A line contains at least 2 points. So it's just talking about a line and a point. So you kind of have to go through and figure out which postulate it's talking about.
So do we just put 2.3?
I put it on multiple choice, so you'll be able to just pick.
I'm so confused.
Yeah, you actually
Okay.
asked me, and I'm still thinking about
Okay. This one says lines. So how many lines is it talking about? 2. Lines S and T. S and T intersect at point D. So if I go back and look at my postulates, which one is talking about 2 lines intersecting at a point? Which one's talking about two lines intersecting at a point? Which?
Right by your hand.
2.6.
2.6, yeah.
Yeah.
Do you guys see that?
Where are you getting 2.6 from? The
Okay, right here. On your paper, like if you scroll up to the top of that assignment,
So every postulate is 2.6?
yes.
Oh,
So like
okay,
there's
okay.
postulate 2.1, 2.2, 2.3. So you're trying to figure out which one matches. And yeah, sometimes it can be a little confusing. This says points A, B, and C are non-collinear. Points A, B, and C determine a plane. So when you look at your postulates, you know it's talking about planes, not lines, right?
2.5.
So I know it's not this one, it's not this one, or it's not this one. So you're trying to determine, and it says points A, B, and C are non-collinear, and they determine a plane. So which one of those is talking about three non-collinear points determining a plane? 2.2 or 2.4. I think I have either one or the other. Okay, so I know it can get a little bit like frustrating. This last one says planes P and Q intersect in line M. So which postulate is talking about two planes intersecting?
That one.
2.7. So that's what you have to do on these. So starting Monday, we're going to start writing proofs. A theorem, which we will learn about, is a statement that's proven true, where a postulate is just a statement of fact. So today we did statements of fact. Starting next week, we'll start doing statements that are proven true, and we'll start writing proofs starting Monday. So I do have a couple jokes. They're stupid. But remember the other day when Nathan was cold and I said go stand in a corner? So I found one that had that. It said, Dad, it's cold in here. Go stand in the corner. Why? It's 90 degrees. So I had to put that on. But I originally had this
Not
one.
always. I got a question. What if the room's like shaped or like this?
Well, then I guess it wouldn't be.
It's like
room is shaped like
45.
that?
So don't go stand in a corner if it's an acute angle, because then it'd be cold.
What
I'm
if
So this says, this kid comes home from school and tells his mom, my math teacher keeps asking me questions. You'd think she'd know this stuff by now. Yeah. Yeah, anyway.
Oh my god.
Okay,
I get it. Chill out.
so on your assignment, the first few, you're deciding whether it's always, sometimes, or never. So this says there is exactly one line through points J and K. Always, yeah, 2 points always make a line. So you go through and you figure out, what do you think about number 2? Points A, B, and C determine a plane. Sometimes. Because they have to be non-collinear, and it doesn't say non-collinear, so sometimes. Good. Okay, so you guys go through the always, sometimes, or never. Then starting with question 7, that's where you're probably going to have to scroll up and look at those postulates. So like 7 says lines. So how many lines are they talking about?
Lines, more than one.
More than one. So lines N and L intersect at point K. Which one of those postulates is talking about lines intersecting at a point? 2.6. So then on number 7, you click 2.6. Does that make sense?
Yes.
I wrote out the postulate also, so if you can understand it by reading it instead of scrolling up and down, you can do that too.
I'm just so tired I can't understand it.
That's question 9, 2.3.
So question 9 says point D is also on the line through points C and K. Yes, I would say 2.3 because the line contains at least 2 points because there's more than one. There,
What would 4 be?
number 4, or which number? 4?
Absolutely always. You know why? Because I said.
Points M and P lie in plane Q. They are collinear sometimes. They don't have to be on the same line. They can be.
So wait, 4 sometimes.
What about
4 is sometimes. I don't know. You should know that one because we talked about it, and I'm not even going to say that one again.
Never.
I meant 4. I mean 3.
Okay, so you go through. There's only 16. I think I may have put it where you can take it more than once. So if you do really bad.
Okay, enter.
So anyway, that's it. Have a good day.